No, I think that personal information is of some importance, and basically I am an engineer with electronics. And later on I got the Bachelor of Science in Metrology, and finally I made a doctorate in climate, as a climatologist, you can say. And the title here is Wind Controlled Climate. And I didn't do anything of this to support myself. I had my own company, so it was actually a kind of hobby. But it's like Peter says, you want to find the answers, and after 4 years and writing this, I actually trying to figure out why there was ice ages. I had to actually give up and say that nobody knows. And Peter, I have to go back to what Peter said here about these Milankovitch variables, which you have to consider them. They are real. I don't get the same answer as Peter do, because the Milankovitch variables can be found as influential in the southern hemisphere temperature variations, but not in the northern hemisphere temperature variations. I have actually curves here showing this. So that's one thing. And moreover, I sent two speeches here, and there became some confusion. And in the program here, I am supposed to speak about the dominant physical processes that cause climate change. And in the book here, I am supposed to speak about global warming and global climate change. But anyway, I will try to accomplish some mixture. Can you go back? Here you see the map of Mars, and if you look at this map, it's one of the most fantastic data gathering features, actions ever taking place. And if you look here, you see a lot of very old craters, impact craters. If you look here, you see deposition areas, sedimentation. If you look here, you have the greatest volcano in the solar system. It's said, it's not my opinion. It's 27,000 meters high, 3 times the Mount Everest height. You have a few more here. Here you have the longest river valley in the solar system. It's about 3,000 kilometers long. In my mind, it's not a river valley. It's about 6 to 7 kilometers deep at certain points. And yes, here I go back to the abstract, which you can find in the book. Nobody can deny that climate is changing and has always changed. The impact of climate change is always regional, never global. And this is important if you want to isolate physical mechanisms that are actually at work. Physics works at the moment you observe it, not because of a certain average over 1,000 years or 100,000 years. But you can use averages to help in understanding the physical mechanism. So here I just show the temperature, reconstructed yearly temperatures from Stockholm, and you see here is the Stockholm temperature, 1760 to 2000. Here is from 1720 to 2000. And the anomalies here, they are not 0.1 degree or something like that. This yearly temperature are about 3 temperatures each direction. And this is usually, they increase if you go poleward. I live in Stockholm at 59 north, and I experienced this. So what I wanted to present or try to transfer, this short article is meant to highlight the concept global and its logical implications relating to climate and climate politics. Let's see how far I can go. The concepts of climate and global. Climate is a concept that is valid for people living in a certain region and whose lives might depend on the long-term variations and so on. Regional climate is well described by the Köppen classification system. For example, when I was in the not Canary, one of the Canary Islands, I had a swim during the morning and went up to the top of Teide and experienced a snowstorm. Now that's different types of climate within 40 kilometers about. So the last 8 ice ages might have had global consequences during the last million years, but there is huge difference in regional climate. For example, along the equator, the temperature difference during summer was less than 2 degrees. During winter, it might have been 3 degrees at the equator, but at the Stockholm latitude, it was about 8 to 10 degrees. So climate change is not the same in every geographical location. Now I want this climate optimum 4,000 to 8,000 years ago was 2 degrees warmer than now. We have to explain that too in one way or another. Yes, I had a computer crash before coming here, so this picture is actually better in your short conference book, yes. So here you see the ice extent in the southern hemisphere, and here you see the ice extent in the northern hemisphere, and I don't see you can see in the conference book the year here. And mostly I would say it is for sure that it has to be warmer in the water and probably in the air too, if you get a less ice extent, and vice versa. So if you want to have carbon dioxide as the input variable, regardless if it goes straight up or straight down or whatever, and the carbon dioxide concentration is about the same in both hemispheres, how can you get opposite curves? This simple graph shows that IPCC don't know what they are doing. I will take some of the examples here because you can read them yourself. The year without the summer, 1815, well known among climatologists, there was a temperature depression over the North Atlantic, the US East Coast, and Central Europe, west of the Ural mountain range. The cold period developed successively and spanned about 5 years, with the maximum impact 1815-1816. Just that year, the Tambora explosion happened. But the Tambora explosion couldn't cause this whole temperature depression. That's a pass to Peter. I want to show this too. This is, yes. In my mind, or maybe I have come so far that if you want to understand what is causing mass motion in the oceans and in the atmosphere, it might be easier to look at the situation on Mars, because you have no water and you probably have no volcanoes at all. And if you observe the wind situation and the wind motion, you will find you might open your mind to other solutions to what is causing mass motion in atmospheres. And here we see how almost global storm develops during 2 weeks on Mars, year 2001. It starts in June, and this is about 7-8 of July. And as you see, it starts from the southern part here and goes to the northern. Will also inform you that about 25% of the Martian atmosphere freezes to carbon dioxide ice during the winter. So the carbon dioxide ice that goes over to a gas has to move. So it's producing a lot of wind. But why is it producing heavy wind only about every 10th year? There is no answer to that question today. Here, this image is showing not a mobile high maybe, but an air mass which is moving from Australia. Darwin is situated here somewhere. And you see how the dry air is capturing energy from the ocean surface, and how these cloud streets develops. And the wind situation over an ocean, the wind can actually pick up energies which can reach 300 watt per square meter. It's more than the average sunshine at the equator, mostly. So you can understand that if there are strong winds during an extended period over a large part of Earth has to cool. And the next piece of information about this is that during the ice ages, the amount of sediments from, for example, salt ice and other types of sediments in Antarctica is 10 times more than it is today. So the wind situation, the global wind situation during ice ages is far stronger than it is today. A climate model is always a simplification. The question is in what limited way it might be useful, or if useful at all. Every model about climate, the aim of it is prediction. And there is not very much use. Swedish climate politics was actually run by people included in the Swedish Academy of Sciences. And here I am writing about articles they wrote in an issue of Ambio, which is a special issue. Here we will look at Olympic Mons, and facts support the opinion that Olympic Mons is a heap of dust. I mean, we know that there are winds on Mars, and we also know that there are excavations of old impact craters. Nobody has shown that there is volcanism on Mars. In fact, everywhere where you do find, you find sedimentary rocks, mostly. The escarpments promote an interpretation of low altitude erosion. If you look here, you see these are 5 to 7 kilometer high, here too, but it's smoother here and here. And here, beside it, you find mountains that are 3 to 5 kilometer high, and probably is an eroded Olympic Mons earlier. It's easy to check on that. All high mountains on Mars are situated close to the equatorial area, where the sunshine drives upwinds along slopes. The caldera of Olympic Mons can hardly be created by volcanic processes. If you look here, You have 3,000 meter deep here, 4,000 there, and so on. These are, and this is 800 kilometer, this is 80 kilometer. 80 kilometer, the features inside cannot be produced by a volcanic mechanism. In my opinion, climate change depends on mass motion induced by factors that we still cannot understand. Read planetary dynamics. Climate change on Mars is easier to understand than climate change on Earth, where water and volcanism to a large extent has decided the surface features. So is not the case on Mars. Finally, I told the free speeches 201 at the geological meeting in Nice. Nobody cared about this information then. But now I give this information to you so you can have an open mind and investigate all this yourself. Thank you very much.